Good day. This is Aloysius Bamdaga, a student at PRA, Masters of Science in Computer Science. I'm presenting a Cache Augmented Generation for my class, master's class. This was done by Brian Cheng and other group of researchers at Cornell University. Let's dive in. So, for a background, retrieval augmented generation systems have been there for some time, but then they had pitfalls or shortcomings, whereby they had reduced latency because of the retrieval system, whereby they have to retrieve data from sources by every time they get a query. That's not practical when it comes to increased systems, when it comes to increased latency, to increase the complexity. Yeah, so if we look into that, augmented generation has gained traction as a powerful approach for enhancing language models by integrating external knowledge sources. However, retrieval augmented generation introduces challenges such as reduced latency, potential errors in document selection, and increased system complexity. The advent of large language models featuring significantly extended context windows. Yeah, so these windows are being used in the Cache Augmented Generation systems to store information, or let's say documents from sources in the before they are converted into a format that is suitable for, or that is understandable by LLM models. Yes, so Brian and the rest proposed in this paper here, which is listed down or referenced down, I proposed an alternative paradigm called Cache Augmented Generation that bypasses real-time retrieval, because real-time retrieval extends inference by the reference time, whereby by the time we get a response after giving a query, there's a lot of retrieval that is happening. But with Cache, there's no retrieval that is required. It's already processed and it's stored in the storage or the disk or the memory of the system, where the element just goes and references to the CKV, which is the Cache key value storage for all the documents required by the query that has been given, or the question that has been given. Yes. So if we continue now, their method involved reloading relevant sources, especially when documents or knowledge for retrieval are of a limited and manageable size, into LLMs, extended context and caching, its running time parameters. So if you go to the next page, so still in the background, now for the first reference is Wikipedia. Cache is a hardware or software component that stores data. So data is stored in Cache when feature requests for the data can be served faster. We have Cache on phones and different devices. So Cache data is easily retrieved because it's already stored or pre-processed. So the data stored in a cache might be a result of an earlier computation or copy of data stored. Now, a cache hit is where we manage to get the data, but then the cache miss is where we can't retrieve the data from the cache. Yeah, so it's different and it's also significant because a cache miss is also downside when it comes to the CAG system, because it depends on the cache to retrieve data. So cache hits are served by reading data from the cache, which is faster than recomputing a result already from a slower data source. Thus, the more requests that can be served from the cache, the faster the system performs, the better. So if we continue, the CAG framework leverages. Yeah, so now we're looking at the methodology. Now, the methodology is broken down into functions, the model function, the conversions, or the formatting of the documents into uh, key values, uh, key value cache storage that can be passed on into the model with a query that the user has provided. All those functions are there to give a response. All those functions are there. We shall see them down. But then let's look at this. So the CAG framework leverages the extended context capabilities of long context LLMs to enable retrieval free knowledge integration. Now, by preloading external knowledge sources, such as a collection of documents, D is equal to D1 and D2. So D1 and D2 are the documents. So this is the input. So D is a list of documents. D1, D2, it goes on sequence. And then pre-computing the key value cache, which is the CKV. Yeah. So the CKV is also computed from the document, which is the D1 and D2. So that's where we compute the CKV. So we address the computational challenges and inefficiencies inherent to real-time retrieval in traditional RAG systems. The RAG systems have issues with real latency and others, as we shall see. So if we continue with the methodology, now the operation of the framework is divided into three phases. Yeah, from getting the document or getting the document or the knowledge from the source to giving a response. We're going to see that process. First, we have external knowledge preloading, whereby in this phase, curated collection of documents, D, relevant to the target application is pre-processed and then formatted, fits within the model's extended context window. Now, so the documents are converted now or formatted to form the CKV or the key value cache, which is stored in the whereby knowledge is stored in form of key values. Key and values stored in the cache and they can be retrieved. So this function here, which is saying CKV, which is the result or the format, is gotten from key encode or key value encode. This function here, key value encode, D, which is the input. So the input is D, which is the document or the knowledge. So the knowledge is input into this function, and then we get the format. The knowledge is converted into this format here. Now, in this first curated document, relevant da, 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 da. Now, the LLM M or the model M with parameters processes the documents, transforming them into a pre-computed cache, heavy cache. Now, when we go to inference, the time between query and response. Now, during inference, the pre-computed key value cache, which is CKV, is loaded up alongside the user's query queue. Yeah, so these two are gotten. They're already formatted. Knowledge is input into the model, which is a function, and then also the query, which has been provided, or the questionnaires that has been provided by a user. Let's say a user wants to use a laser DeepSeek. So they input that cache. They input the key value and also the cache into the model. Sorry, the question into the model function, and then we get a response. That's where you see the response is equal to the model function with input, the query, and also the key value cache. So we have to look at something called cache reset. Now, cache reset is where now to maintain system performance across multiple inference sessions, to maintain the performance for inference whereby there's a lot of query and response, whereby someone is asking ChatGPT or DeepSeek a lot of questions. Yeah, so we have to probably maintain a system. So that's where we have to eliminate untruncate tokens that have just been input so that we can maintain a system that is probably efficient. Now the KV cache or stored, the KV cache stored in memory can be reset efficiently. So this is gotten from the memory. So the memory is truncated. Yeah. So as KV cache grows in an append-only manner with new tokens, 1, 2, sequentially appended, resetting values I'm getting these new tokens. C, reset, KV. Yeah, so we continue the methodology. Yeah, so the Cache Augmented Generation methodology offers several significant advantages over the RAG system because the retrieval system has that additional functionality of retrieving, which is probably okay. It's not probably outdated, but it's just not as efficient as the new system, which is the Cache best system. So there are advantages, or there were. With the rank system, there are rules, shortcomings, shortfalls. Oh, yeah. So these were solved with a Cache Augmented Generation. So one of the shortfalls were reduced inference time. So one of the gains that happened, or the gaps that were filled, a reduced inference time, whereby there's a reduced time between someone asking a question and getting a response. So they eliminated the need for real-time retrieval. The inference process becomes faster and more efficient, enabling quicker responses to the user queries. Then the next thing is unified context. The LLMs understand the data more and they give better accurate responses. Now, preloading the entire knowledge collection into the LLM provides a holistic and coherent understanding of the document, resulting in improved response quality, consistency across a variety of tasks. Then the third one is simplified architecture. Yeah, so of course, removal of retrieval. You see, when you remove retrieval, a lot happens. Reduce inference time and not simplified architecture. But then to understand more, of course, the CAG system has a format in which the data is understandable by the model or easily understandable by a model. The format is easily understandable at key value format that's stored in the cache, easily understood by the model. So let's go to the methodology. Now this is where it gets interesting. So we have the CAG and the RAG. We have to compare the before and the after, the future and the past. So here we're looking at the Cache augmented generation. So here, if you look down here, we have our knowledge source where we plug it into our preparation stage, whereby the LLM has to convert, or the model has to convert the knowledge or the documents into the key value cache format, and then it stores it into its memory or disk. So when it's stored into its memory or disk, that can be referenced when someone gives a query. So when someone gives a query, we come and pick our query, then we place it into the model function or the LLM function, this llama. And then we also input the key value that is probably concerned with the query or that can feed a response to the query. So a response is generated, which is R, as we saw in our function here. Yeah, so this function here, R is equal to M. So that's where you get the query. And then this is the format that is gotten, the knowledge format that is gotten from the storage in the memory disk or the cache. So that's why it's called cache augmented memory. Augmentation means incrementing, yeah, increment in memory or something like that, increment in knowledge or increment in speed, increment in, I don't know, it's just increment. So we get a response there. But then if you look at the RAG, so the vector database picks the or retrieves the knowledge from the source, and then after that, you get to have query knowledge with best matches. So best matches have to happen similarity query encoded. The query is encoded, and then yeah, it fit the best matches. Then knowledge with the best matches. So just like happens like query and key value querying here with key value cache, but here it's just querying and knowledge with the best matches. So everything is matched and it's feeding into the LLM. So this is the Q and this is the CKV. The substitutes for the CKV here or the key value cache format that is fed into, and this is the knowledge. So we have best matches here, knowledge with best matches. So it's fed into the model with a query, and we get a response through the LLM or the llama. Yeah, so if we continue, I think that is simplified. If we continue, some more explanation of the CAG methodology. So we go and still look into the CAG, we simplify it further. So the first, let's look at the KV cache generation. Now, the knowledge documents and sources are changed into a format that can be understood by the model. Yeah, first of all, the source, the knowledge documents, let's say someone asks about dogs. Yeah, no, this knowledge or the documents are picked from the source because I think, yeah, the format is picked in terms of documents. So documents are picked from the source and then they are changed to a format that are understood by the model. Guess the format. Now that format is a key value cache, which is generated by the LLM. Let's say Llama. Now this is stored. Now this stores intermediate states of the attention mechanism and also packages the model's understanding of the preloaded documents. Yeah. Okay. So the understanding of preload is like unified context. So this also improves the model's understanding of the probably task at hand. So we go to the next thing, which is the cache or the KV cache storage. Now this is the format in which the model understands. Now the KV cache storage is stored in a disk memory for reference when the model is required. Yeah, so this is stored in a disk. That's like how we saw here. That's like how we saw here in this diagram. We saw now this is the memory. So here it's picked. This is the memory here. Now it's transferred here. So this memory here is where we pick the, the key value um, uh, storage from, and then we can refer to the knowledge that was being formatted or changed into key value format. Yeah, so that cache or storage has the key value knowledge in terms of the knowledge in terms of the key value format. Now, for inference, between the process between query and response, I already say that now the model compares the key value cache or key value storage with the user's question. So when someone asks a question, now inference is where someone asks a question, then we go to our KV storage or KV cache memory, and then we pick our key value that is relevant for that question, or the accurate answer for that question, or the accurate answers to that question. Then we go and put them in the model. Then the model generates the accurate answer. Actually, I think we get something maybe best matches just like in the rag, and then fed into the model as input, and then we get an error, which is the output. It then generates responses without retrieval of knowledge. There's nothing like it's I don't know. It's not that there's no to and fro. It's just like getting water probably from a well or a borehole. And for the borehole means more inference. uh, sorry, slower inference. Then a nearer borehole means a faster inference. It means if the water is already processed, then it means that water is going to be easier to be what? To be utilized. Maybe drunk if it's already what? Uh, in case it's already cleansed. Yeah, so this inference here, when it's reduced, or when the time is reduced, the faster inference gives reduced latency compared to with RAG. So if we go to the next methodology still, now to evaluate the effectiveness of the proposed method, now we are looking at a paper that was written by Brian and Tim, the researchers from Cornell University. So they conducted experiments on two widely recognized question answering benchmarks. The Stanford question answering dataset, which is SQUAD 1.0, and then also the output dataset. Now, the datasets have the same format of probably content. And these datasets provided complementary challenges, with SQUAD focusing on precise and context-aware answers within single passages. Then Hotpot emphasized multi-hop reasoning across multiple documents. Multiple reasoning. Wow. Okay. Now, each of both datas consisted of documents D, which is D1 and D2. Now, this is what we feed into our CQV to get to get CQV. This is what we feed into our this formula here. Yeah, this is what we feed into our KV.encode this D. So all those documents are fed D1, D2, D3, D4, D5, D6. All those are fed to get CKV to get the key value formatting in the cache memory. And then they were paired with questions which are Q1 and Q2. Now these questions would be used to be fed into the model so that we can get a response. Now these questions are here, which is the Q. So the response is equal to the model function when we feed in our CKV, which we have gotten through adding the D1 and D2 and D3, which are the documents or the knowledge. So the documents and the knowledge in this format that is easily understood by the model are fed into the model, which can be a llama. So the query which the person has asked and let's say the best best knowledge is fed in terms of the CKV format, is fed into the model, and then we get a response. Faster inference. Yeah. No retrieval. That's what you're looking at. So then they were paired with questions, then a set questions, and then also a golden response, which is R. So even responses were given. Yeah, so for validation. Yeah. For training and validation. So we continue to our end or our last page, which gives references. Now, so we had different references, but the one you should look out for was by Chan, Brian J, Chen, King, Wang, which says, don't do RAG when Cache Augmented Generation is all you need for knowledge tasks. Yeah, that's the paper. But other than that, that's the team from Cornell University. They did a very good job because this impacts society through science. Now, when there is an impact in science, there is an impact in society because theory is applied. When theory is applied, that's when we see impact in society, and that's the motivation for all we do to impact society positively, not negatively like people fear about machine learning or AI practices. Yeah, so that is it, and this is Cache Augmented Generation. Thank you.